Okay, everybody's basically ready. So last time we had talked about how to improve the simulator, about how to improve the framework by not repeating the definitions of animals. So fox and rabbit had a lot in common, so we moved all the code that was in common to a parent class called animal, and that let our fox and rabbit classes be a little bit smaller. And if we were going to make a new animal, it would be faster to make it, because our new animal, weasel, we could just say weasel extends animal, and we'd get all the basic animal stuff without having to type it in. So that's all behind us. The problem is, in simulator, we're still treating all these different animals differently. But in a certain sense, we could treat foxes and rabbits and weasels as all the same, because they're all kinds of animals. They're all specialized sorts of animal. So that's what polymorphism is going to end up being about. So instead of doing the same thing for each type of animal, like repeating the code, it would be really great if we didn't have to have new loops for each animal. We could just loop once for all the animals. And that's what it's going to be. Okay, so the visually most obvious thing is this for loop looks the same as that for loop. And if we look at the comment, it says loop through all rabbits, let each rabbit run around. Loop through foxes, let each fox run around. But if you notice, actually, the line above the for loop and below the for loop is also the same for both. Because when the rabbits are running around, one of the main things they do is have more rabbits. And so this line up here is about creating a list that will hold the babies. And down here, we have to take the babies and add them to the list of all the rabbits in the simulation. So if your box was didn't include those two lines, expand it to include those two lines. And then here's that same set of things for foxes. Okay, so that's what's the same in both. What's different in both, obviously the data type, like this is all rabbit and this is all fox. But rabbits run and foxes hunt. And that's like a main difference as well. Related to that difference, when you tell a rabbit to run, you only have to give it two inputs. You only have to tell it what's the new field and give it this sort of like empty storage place for its babies. For the fox, you have to give it both the current field and the updated field and give it the storage for its babies. So the number of inputs here, and actually go ahead and write 2 inputs and 3 inputs, just because this is going to be important later. Okay, so we're on the backside. So here's what would be nice. Right now, if you look at my finger and pen, we've got a fox list that has a bunch of fox objects. And that loop on the front page like looped over every fox, and it said, fox, you hunt, and now you hunt, and now you hunt, and now you hunt. And then for the rabbit list, rabbit, run, 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 run. That's how the front page was working. What would be really great is if instead of this, let's cross that out, instead of this, we had just a single array list whose data type was animal. And inside the animal list, some of the locations hold fox objects, some of the locations hold rabbit objects. So we can just hold all the objects in one place, and we don't have to have a separate list for each kind of animal. So that's what we're going to try and do. So if that's what we're going to do, how is it going to work inside Simulate One Step? So notice these have the same kinds of lines as the front side. So before it said list rabbit, new rabbits equals array list rabbit, and that was for like baby rabbits. Here I'm making it data type animal because I don't know what kind of animal it's going to be. It could hold a fox, could hold a rabbit. And now I'm going to loop through my whole animals array. I'm not looping through the fox list, not looping through the rabbit list, I'm looping through this animal list. And then this line right here, where I'm getting the element I, so like let's say I equals 4, for example, I'd say animal list, give me the thing at 4. The thing at 4 happens to be a rabbit, so now I've saved my rabbit object into this animal variable called animal. So now we get to the problem, which is, well, that was just an example. The question was, why is it 4? And the answer is, it's actually, the I values here are looping through the whole list. So we're actually visiting every single location one at a time. And so just, for example, if I were 4, we would grab a rabbit. But remember, rabbits run and foxes hunt. So if you were writing this code, you might think you'd have to do something like this. You'd have to say if, sort of in pseudocode, we'd say if animal is a rabbit, then you'd run the rabbit method. You'd say animal.run. And then you'd say, okay, that's if it's a rabbit. If animal is a fox, then let's run the fox method. And I'll say animal.hunt. So it doesn't really seem like we've saved a whole lot of code because we still need to test what kind of thing do we have and have it either run or hunt or whatever its special method is. So we're not going to do that. What we're going to do instead is we're going to give all animals a method called act. So what used to be run for rabbits is going to become act. What used to be hunt for foxes is going to become act. And then this will just magically do the right thing. If the animal variable has a fox and I run act, it will run the fox version of the act method. And if it's a rabbit, it will run the rabbit version of the act method. The name for that is polymorphism. And I'll say like one more word about how that makes sense at the end. The question is, run took 2 inputs, hunt took 3 inputs. How do we make it all work? So in order for this to work, when we make that act method in animal, we have to give it all the information that any animal might need. So we're going to give it 3 inputs, and the rabbit might just ignore the input that it didn't need. So there are 2 things that make the code above actually work. The first thing is child objects are allowed to be stored in variables of the parent data type. So, for example, let's imagine up here we've got animal, and you should go ahead and draw animal and fox and rabbit here. Here's fox. Here's rabbit. Fox extends animal, rabbit extends animal. Okay. So here is a thing that is totally allowed. What's totally allowed is I could say animal Bob equals new, and I don't have to say animal, I could say new fox. So this is okay. And here's a way of thinking about how it makes sense that it's okay. What it means for fox to extend animal is a fox gets all the animal code, so it can do anything that an animal can do. So in that sense, a fox is a kind of an animal. So it makes sense that you could save a fox object into an animal variable, because anything you might ask an animal to do, you could ask a fox to do because it's got that same code. So that's sort of why that makes sense. Let's think about the other way around. Could I have a fox variable named Sally? Well, I could have a fox named Sally, but the question is, could I create an animal object and save it into the fox variable? Okay, and now the video's playing. Recapping what we just said. Because fox extends animal, foxes can do all of the code that animals can do. So that's why it makes sense to store fox there. The reverse is not true. So foxes may have additional methods that animals don't have. So it would be a lie to put animal inside a fox variable, because that would be claiming the animal object can be treated like a fox. But foxes may have methods that animals can't do. So that's how come we're allowed to store all of our child class objects in a single list called animal. It's that fact. Okay, there's a second fact related to the running of this act method. So let's pretend we have a method in animal called act. And let's say it's got 3 inputs, the same 3 inputs that are in hunt on the front page. But let's say that the animal version of act, there is no method body. So it's just like empty. Like you got a method there, but if you run the method, nothing happens. So now let's say rabbit. Formerly, rabbits had a run method. Let's cross run out, and let's rename it act. But let's give it those same 3 inputs. Okay, there's a super important word now. Here's the word. Act has been overridden. So the idea of overriding a method means that your child is redefining the behavior of the parent. So the parent might have something it means to do the act method. Now the child version of act is just going to do something totally different. The question is, whoa, hold on, the run method had 2 inputs, so shouldn't act have 2 inputs? So here's a subtlety. In order for the code up here to work, the rabbit class has to override the parent method. But just because they're both called act doesn't mean it's overriding it. They have to have the same name, and they also have to take the same inputs in the same order. So if everything about the method's signature is the same, that's what creates the magic right here, where like no matter what kind of object is inside animal, if I run act, it's going to be the correct child version of act. So if animal is a rabbit, it'll run the rabbit version of act. And if animal is a fox, it'll run the fox version of act. That's polymorphism. Let's do some like word meaning stuff. Like poly, what does poly mean?
Multiple.
It could mean change, it could also mean multiple. Morphism, morph is about forms. So polymorphism is about multiple forms. What is the method that has multiple forms? It's act. Right, so act has many forms. So polymorphism, if you want to sound really fancy, try this out. Act is a polymorphic method. Okay, the excellent questions continue. So if act in the parent is empty, why even have it? Why not just have no act method at all and have the children have act? In order for the polymorphism to work, in order to run the right child version of act, the parent act has to exist and the children have to override it. So if you left this out, foxes and rabbits both have an act method, but we wouldn't be able to use the polymorphism up here. It wouldn't just automatically run the right version. That's why. So our last wonderful question is, if I save a fox object into an animal variable, don't I lose some information? Here's a good way of imagining kind of what's happening with the variables. So here so variables are like boxes that hold values. And the data type is like the label on the box. So here in my garage, I have a box whose label is animal. And the label tells me what the thing inside the box can do, what I can treat it as, what I can do with it. And I don't know what's actually inside the box. It might be a fox object, it might be a rabbit object, it might be something else. But all the things inside that box can be treated as animals. But just because I put a fox inside a box doesn't mean that it stopped being a fox. It's still a fox in there. So I didn't lose any code. I didn't lose any abilities. But what is true is that once I've put the fox in an animal variable, I can only run animal methods. Unless I was going to take the object and put it in a different box labeled fox. If that is confusing, no worries. We're going to talk about that detail more later, and that detail isn't relevant for our current code.